Perfect. Okay, so can anyone tell us what does this function do from this point till this point? So let's say from point A to point B. What does the function do?
Increases.
Excellent. And at any point in time, thank you, Brianna. Okay, at any point in time, or at any point on this piece from A to B, if I want to draw the tangent here or here, can anyone tell us what is the sign of the slope of the tangent?
It's positive.
Positive. So here is our first remark. F increases, F prime positive. Good. So please, this is our first note. Can anyone tell us what does the function do between B and C?
Decrease.
This decrease is very good. At any point, if I draw the tangent, can anyone give us the slope of the tangent when the function is decreasing?
It's negative.
Very good, awesome. So the function decreases means the first derivative is negative. Good. So now, let's go back. We want to continue with the table. Okay. So can anyone tell us the sign of this expression? So I just want to copy it here so I can. So f prime of x is x minus 2 squared. So obviously I determined the critical number, but now I want to find out what does the derivative, what is the sign of the derivative here, and what is the sign of the derivative here. So what is the sign of x minus 2 squared? I just want the sign. You can plug in numbers to the left of 2 if you want, or to the right of 2, and just tell me what is the sign.
Positive.
Very good. It's always positive. It's 0 at 2, and it's always positive. So if the first derivative is always positive, what does the function always do?
Increases.
That's it. Because the first derivative is positive, the function will always increase. A function that is always increasing, does it have max min? So this is the critical number. But does this turn into a max or a min?
No.
No. Excellent. So no points of extrema. Why? Because the derivative never changes sign. What does this mean? Never changes sign. So let's take a look. If the derivative is positive, the slope is positive, then it's 0, and then it's negative. From positive to 0 to negative, this is a maximum. The derivative changed sign from positive to negative. What if it changes sign from negative to positive? Negative, 0, or maybe undefined, and positive. What type of point is that? A minimum. So if it changes from negative to 0 or undefined, and then positive, from negative to positive, this is a relative or local minimum. But here, the derivative is like this. Positive, 0, positive. See, there is no turn. It's not a max or a min. The function does this at all times. So it's only increasing. If it's always decreasing, the same thing. It will not have a point of extrema. The point of extrema are also called turns. The function turns. from coming down, decreasing, it turns and it's increasing. From increasing, it turns and it's decreasing. Here there is no turn, meaning there is no point of extrema, there is no max min. Very good question. Okay, let's choose one more and move on. I didn't mean that. I meant this. So let's look at another.
Can we do 28?
28, where is it? Here, good. That function also will not have a point of extrema. It's a rational function. It will not. So allow me to choose one that has a point of extrema because we want to illustrate that. It's going to be the same thing. Okay, so let's take a look at another. Well, let's look at 12. So g of x equals to, no. See how I'm copying from a different problem? So f of x equals 3x squared plus 2x cubed. Okay, good. So in order to discuss points of extrema, I have to find critical numbers. If critical numbers if the function doesn't have critical numbers, then there is no max min. So we find f prime, and we know that critical numbers come from two sources, from f prime of x being 0, or from f prime and undefined. But this is not the case because we chose another polynomial function, so it's not going to happen. Okay, then, so let's take a look at f prime. So f prime of x, can anyone give us the f prime?
6x.
Very good, 6x indeed, and plus
6
x.
x2.
Very good, awesome. So we want f prime being 0. So 6x plus 6x squared equals 0. Remember two key words, simplify and factor. At all times, this should be in the back of our minds. And of course, I'll divide both sides by 6 and arrange it correctly as x squared plus x equals 0. How do I proceed? What would be my next step here?
Factor out an x.
Very good. So an x plus 1. And we have two critical numbers, 0 and -1. So these are the critical numbers of this function. Do we know whether they turn into max min? We have no clue. Absolutely no clue. Okay, so back to our table. That's why I insisted, please understand this table, please. So f prime of x, f of x. I know it's a polynomial. I know you will say all real numbers. I know you will say to put in the table the two critical numbers, to put the 0 underneath them for f prime. That's how we got them. We set f prime equal to 0, and we got -1 and 0. Now I need to determine the sign of the derivative here, here, and here. So remember, I'm going to copy here the derivative, f of x. F prime of x is, and I'm going to put it in correctly, so 6x, x plus 1. That's our derivative. Because I have to keep the 6. It doesn't make any difference for the sign, but that's our derivative, right? 6x plus 6x squared with 6x squared, and 6x. Good. So please pick a number between -1 and negative infinity and -1, and just give me the sign of this expression. So pick -10 and tell me the sign, and I'll put it in.
Negative?
Yes, absolutely. So -10, oh, I'm sorry, it's positive. So -10 with -9, -10 with -9 will be positive, times 6 will be positive. So now let's choose -0.5. Negative 0.5, negative 0.5 times plus 1. So this will be positive, this will be negative, this will be positive. What is the sign of the derivative between negative 1 and 0?
Negative.
That's it. Now try 10, of course, you're going to see positive. At this point, I have to determine these values. So I go back to the original function. I'm going to copy it here. So it's 3x squared plus 2x cubed. There is no need to put this function in the graphing calculator because it's quite easy to plug in negative 1 and plug in 0. When we plug in 0, what do we get?
0.
Perfect. And when we plug in negative 1, this will be 3, and this will be negative 2. So 3 minus 2?
Positive 1.
Positive 1. Very good. Good. So now let's analyze what's happening here. The first derivative is positive. What does the function do?
Increases.
Very good. Awesome. The first derivative is negative. What does the function do from 1 to 0?
Decreases.
Excellent. And then, of course, we did not determine the end behavior. We will. This is just the preliminaries to understand the relationship between the critical numbers and max-min. And, of course, you're going to say it's increasing. Look at this situation. The point negative 1, 1. The derivative is positive. The derivative is negative. What type of point is negative 1, comma 1? Very good. Relative or local max. Perfect. Now let's take a look at 0, 0. The derivative, then 0, 0 here, and then the derivative. What type of point is 0, comma 0?
That's a relative minimum.
So we found that this function has negative 1, 1 relative max and has 0, comma 0 relative min. It had critical numbers and also the derivative changed sign. It can have critical numbers, but if the derivative does not change sign, there is no max min there. Any questions?
Are you able to show us one where the second rule you talked about applied? That's not a polynomial function.
You mean how to find critical numbers from f prime being undefined?
Yeah.
Sure. Here it is. So we have f of x equals the cube root of x. Okay. So let's determine f prime of x. In order to determine f prime of x, it is wise to change this function into x to which power? Anyone?
1/3.
Thank you very much. So we bring 1/3 in front. X, we subtract 1. So 1/3 minus 1 will be negative 2/3, which changes into 1/3 the cube root of x squared. It's negative, so it goes to the denominator. And x to power 2/3 is the cube root of x squared. So we are trying to, this was a different question. So we are trying to find critical numbers. What is the domain of this function? Can anyone give us the domain of the cube root of x and y? Anyone?
All real numbers.
Of course. It's the cube root. The cube root has domain all real numbers. If I change, and I don't want to write it here, but if I talk about the square root of x, that's a different situation. The domain is 0 to infinity. But as long as the index is odd, the function will always be defined everywhere. This is a different story. When the index is even, the quantity has to be greater than or equal to 0. But here, anything goes. I can take the cube root of -8. I can take the cube root of 0. I can take the cube root of 1, -1, any number. So now, look at what happens. So f prime, source number 1 equals 0, and source number 2, f prime of x, being undefined. So can 1 over 3, the cube root of x squared, be 0? In other words, I'm asking, when is a fraction 0? If I have a divided by b and I say this is 0, in which situation will this happen? Only if?
A is equal to 0.
Only if a equals 0. Can a be 0?
No.
No. So no critical numbers will come from f prime being 0 for this function, because f prime will never be 0. Now I go back to the function, the derivative, and I'm asking, is this function f prime of x, 1 over 3, the cube root of x squared, is this ever undefined?
And x equals 0.
Yes. When x equals 0, f prime will be undefined at x equals 0, so this becomes a critical number. Will it change into a max min? No, because this is always positive. It will not, but it's a critical number. And it does not come from f prime being 0, but it comes from f prime being undefined. Is this what you had in mind?
Yeah, thank you.
Thank you.